Do you know how old the universe is? It's 13.8 billion years old. The first stars ignited around 200 million years after the Big Bang, but galaxies took billions of years to form. Humans have been trying to understand the world for almost as long as we've been around. We started with animism, then moved on to mythology and eventually to science. Today, we're going to talk about some interesting facts about physics, one of the most fundamental sciences. Here are some unbelievable facts about physics that will blow your mind. Light travels faster than sound. That's why we see lightning before we hear thunder. This fact has been known since ancient times, but it wasn't until the 17th century that scientists began to understand why. Isaac Newton developed his corpuscular theory of light, which stated that light was made up of particles that traveled in straight lines. This was later disproven, but it laid the foundation for the development of the wave theory of light, which states that light is made up of waves that travel at a constant speed. Albert Einstein built on this theory, developing his special theory of relativity, which postulates that the speed of light in a vacuum is the same for all observers, regardless of their relative motion. This means that, no matter where you are in the universe, light will always appear to be traveling away from you at the same speed. Nothing can travel faster than the speed of light. This is one of the most well-known laws of physics. According to Einstein's theory of special relativity, nothing can travel faster than the speed of light in a vacuum, which is approximately 299,792,458 meters per second. This has been proven through numerous experiments, and is generally accepted to be a fundamental law of the universe. However, there are some areas of physics that suggest that it may be possible to travel faster than the speed of light under certain circumstances. One such area is quantum mechanics, which deals with the behavior of matter at the atomic and subatomic level. Some physicists believe that it may be possible to create a wormhole, which is a theoretical passageway that connects to different points in spacetime, allowing for faster-than-light travel. However, the existence of wormholes is purely hypothetical, and there is currently no evidence that they actually exist. Other physicists argue that it may be possible to bend the laws of physics to allow for faster-than-light travel by creating a warp bubble, which would essentially be a region of spacetime that is distorted to allow a spacecraft to travel faster than light. Again, this is just speculation, and there is no concrete evidence that it is possible, or even theoretically sound. While faster-than-light travel remains a popular topic in science fiction, it is generally regarded as impossible within the current understanding of physics. Time is an illusion. This is a controversial statement, but there is some truth to it. According to Einstein's theory of general relativity, time is not absolute but is relative to the observer's frame of reference. This means that time can pass at different rates for observers who are moving relative to each other. For example, if you were on a spaceship traveling at a significant fraction of the speed of light, time would pass more slowly for you than it would for someone who is stationary on Earth. This phenomenon is known as time dilation and has been proven through experiments with atomic clocks. So while time is certainly real, it is not the same for everyone. It is a relative experience that depends on your frame of reference. Gravity is not a force. Gravity is a fundamental interaction of nature, but it is not a force in the traditional sense. According to Einstein's theory of general relativity, gravity is a curvature in spacetime caused by mass and energy. Objects are attracted to each other because of this curvature, not because they are exerting a force on each other. To understand this, imagine a bowling ball placed on a trampoline. The ball causes the trampoline to sag or curve inward. If you roll a marble across the trampoline, it will be pulled toward the bowling ball because of the curve in the trampoline's surface. Similarly, massive objects like the Earth create a curve in spacetime, and other objects move toward them along the curved paths. So while we experience gravity as a force, it is really just the effect of objects moving in response to the curvature of space. Quantum entanglement is real. Quantum entanglement is a strange and mysterious phenomenon in which two or more particles become linked together in such a way that they share the same properties, even when they are separated by vast distances. This phenomenon has been proven to exist through experiments and is one of the foundations of quantum mechanics. Entanglement has some mind-boggling implications, such as the idea that two entangled particles could communicate faster than the speed of light. However, this does not violate the laws of physics, because no information is actually being transmitted between the particles. Entanglement is a correlation between the particles that cannot be used to send messages. Despite its strangeness, quantum entanglement is a real and well-documented phenomena that has been studied for decades. It continues to be an area of active research and may have important applications in fields such as computing and cryptography. There are more dimensions than we can perceive. This is a controversial topic, but there is some evidence to suggest that our universe has more dimensions than the 3 spatial dimensions and 1 time dimension that we experience. String theory, a theoretical framework that attempts to unify all the forces of nature, requires the existence of at least 10 dimensions. While we can only perceive 4 dimensions, the other 6 dimensions are thought to be curled up at extremely small scales. There is some evidence for this from particle physics experiments, but it is still far from conclusive. If there are additional dimensions beyond the ones we perceive, it could revolutionize our understanding of the universe. However, it is important to note that this is still a highly speculative area of research, and there is no consensus among physicists. Atoms are the smallest unit of ordinary matter that retain the chemical properties of the element to which they belong. They are incredibly tiny, measuring just a few femtometers in diameter, but everything in the universe that we can see is composed of atoms. This includes stars, planets, animals, plants, and even the air we breathe. All of these things are made up of a variety of atoms, each with their own unique properties. For example, the star you see in the sky is mostly made up of hydrogen and helium atoms, while the water you drink is composed of molecules made up of hydrogen and oxygen atoms. Understanding the properties of atoms is essential to understanding the world around us, and modern technology allows us to study atoms in greater detail than ever before. Nothing can move faster than the speed of light. In a vacuum, Albert Einstein's theory of special relativity tells us that nothing can move faster than the speed of light, which is approximately 186,000 miles per second. This is because as an object approaches the speed of light, its mass increases infinitely, requiring an infinite amount of energy to accelerate it further. However, there are some exceptions to this rule. In certain circumstances, particles can move faster than the speed of light. This phenomenon is known as Cherenkov radiation and occurs when a charged particle moves through a medium such as water or glass at a speed greater than the speed of light in that medium. When this happens, the particle radiates electromagnetic energy, which can be detected as a blue glow. This effect is similar to the shock wave that is created by a boat moving through the water faster than the speed of light in water. The blue glow emitted by the charged particle is due to the fact that visible light has a shorter wavelength and higher energy than other types of electromagnetic radiation. As the charged particle moves faster than the speed of light in the medium, it creates a disturbance that emits radiation with a wide range of wavelength. However, the peak of this radiation is in the visible spectrum, resulting in a blue glow. All of these facts are truly amazing and show just how incredible the world around us is. If you enjoyed this video, make sure to leave a like and subscribe for more videos about space and science. Thanks for watching.